Now we're going to look at what it takes to design an experiment. First of all, it helps to know the parts of an experiment. Again, kind of reviewing, the experimental units or the subjects, that's one part. The explanatory variable, in other words, the thing that you think is going to make a difference, like hormone replacement therapy in the previous video. The response variable, so the thing you're going to measure, what kind of effect are you looking for? In the previous video, we talked about the risk for heart attack. The treatments, well, you could give the hormone replacement therapy, I can't speak right now, or you could give a placebo. Those are the different types of treatments. So let's go ahead and look at a different experiment. And this is Career Start. It was a program they developed. They're like, okay, if we link the knowledge that they're learning right now to their careers, then they're going to do better in school. So here's what they did for their experiment. They recruited 14 middle schools in Forsyth County, North Carolina. And so if I'm looking at the experiment, these are the experimental units, the schools. Now, another important part is they selected 7 of the 14 schools at random to use Career Start plus the normal curriculum. Then the other schools used the regular curriculum. There's a little bit of a finicky thing when you assign at random, and I want to make sure you don't fall into a trap, and that's going to be another video. Now, for this, we're thinking the explanatory variable, the thing that's going to explain the difference in performance, is going to be Career Start. And the two treatments are either we do normal curriculum plus Career Start, or B, just the normal curriculum. So which one works better? Sometimes doing more, it's difficult. As a teacher, I can tell you, sticking more in the classroom is hard. Okay, so then the researchers collected data on attendance, behavior, test scores, levels of engagement, and graduation rates. All of these are things we're going to measure. All of them are response variables. Now here's another way to look at the experiment. So you can see here I've got my 14 middle schools that are participating in the experiment. Then I'm going to randomly assign them. And this isn't hard, but you have to make sure to do it right. Okay, so I'm going to randomly assign them to either Group 1 or Group 2. Group 1 is going to have Treatment 1, which is normal curriculum plus Career Start. Group 2 is going to have Treatment 2, which is just the normal curriculum. Then I'll compare the attendance, behavior, test scores, engagement, and graduation rates. By the way, here's a hint for your AP test, and I should have labeled this on the slide, but here we go. Doing this on your free response for your AP test is a good thing, as long as you list some more detail. This doesn't have enough detail to explain your experiment. Now, if you decide to skip this and write a paragraph about what you're doing, that will be sufficient as long as you are addressing all of the information they're asking for. So, if I have this graphical view, let's go ahead and highlight some important parts. The 14 middle schools are the experimental units. The Career Start, we're pretty sure that's the explanatory variable. Then how are we going to level it? Have different factor levels there. Well, we'll have Treatment 1, which includes Career Start, and Treatment 2, which does not. Okay, so those are our treatments. And finally, our response variables are attendance, behavior, test scores, engagement, and graduation rates. So there are also 4 principles of experimental design that you should use. 1, there's control. Now you might see slightly different wording in different books, but for your book it says control, and we're okay with that. We control factors by assigning different factor levels. Okay, so we control that. They don't pick it, we do. Also, we randomize. We control for known or unknown confounding variables by making random assignments to the treatment. So we're going to randomize there. Then we replicate. One data point is an anecdote. That's not good enough. We need multiple data points. So we need to first get enough subjects so the sample size is good. Then we really should repeat the experiment. It's nice to use a pilot experiment first and then do a full scale. So this reminds me, and actually your book mentions it, the cold fusion fiasco. I was actually in college at the time at the University of Texas, where they have this really cool big fusion reactor that they're trying to make called the tokamak. It's underneath the physics and math building. It's huge, all right? And then that year, I remember, I think it was 92 or somewhere around there, a little earlier, somebody somewhere said, hey, we can do cold fusion. We can actually achieve a fusion reaction in a glass of water. They were so excited. They didn't want to get beaten to the punch, and they said, we're going to publish our results. Well, they only did one experiment. No one else could replicate their experiment. And so they were kind of embarrassed at the end. So anyways, if you ever hear about cold fusion, think about replication and making sure you can repeat your experiments before you publicize. Now, the final principle of experimental design is block design. So we can create groups for attributes that we can't assign or control, and then randomize within those groups. I'm not going to cover that so much in this video. I'm going to wait till we do the last part of chapter 13. Okay? All right, so what's important about control and randomization? We can only really compare the effects if the groups that have the 2 treatments or 3 treatments or whatever it is, if they're similar. Okay? Well, experimenters might say, well, I'll make them similar. I'm going to go ahead and make sure that my people match. I'll have somebody that's 50, like your old teacher, in one group, and make sure I have a 50-year-old in every group. And I'll make sure I'll have a high schooler in every group. So they're going to try to match by age or gender or physical condition or if they're a smoker or not. It's helpful, but it's not good enough. All right. So what we rely on, and it's almost like magic, we rely on chance to make an assignment that doesn't depend on the characteristic or the judgment of the experimenter. So we actually, it's crazy, but when you do chance, it gets rid of a lot of the things that can confuse us. One last thing on this video, what we're looking for at the end of this experiment is something called statistical significance. We want to see big differences. So if the differences look kind of like what you'd get anyways by chance, that's not a big difference. But if we do see an effect that's so big that you can't really explain it by chance, then we say, ooh, this is statistically significant. We can actually establish like a causal relationship